The General Dynamics VTOL ducted fan system is a remotely controlled, autopilot stabilized, independent ducted fan. This system was originally conceived as a surveillance system. However, it has numerous close support applications. General Dynamics VTOL ducted fan studies were initiated in 1959. In April 1961, an effort was undertaken to demonstrate concept feasibility of a small, lightweight, unmanned airborne system that was capable of vertical takeoffs and landings from an unprepared site. A tether rig was developed for use as a system checkout and training device. The tether rig provides restraint for the vehicle and safety features for both the vehicle and operating personnel. Crew training and system checkout were both successfully accomplished by use of the tether rig. The demonstration unit was first tether tested just 30 weeks after the start of the feasibility program. The unit was flight tested next with only safety lines attached. The rugged airborne unit can take off and land vertically. It can hover or translate in any direction in a stable and controllable manner. Instantaneous control is possible, indicating adaptation for pop-up, over-the-hill surveillance. The demonstration unit weighs 235 pounds. The engine power is fed to a set of two-bladed, contra-rotating propellers which provide lift while minimizing rotational torques and gyroscopic effects. The operator remotely controls position and motion of the airborne unit with a simple set of controls. The operator's commands are transmitted to a conventional autopilot, which activates the throttle control and the control vanes located in the shroud exit area. This simplified actuation system provides complete control of the airborne unit. The vehicle is recovered without the use of a parachute, thus eliminating ground impact damage. The ducted fan enclosure enables the unit to be handled without hazard to operating personnel. Four-man assist landings have been used, but mechanical pull-down recovery by one man is feasible. Successful remotely controlled free flight tests were made in June 1962. During the first free flight test, balloons were restrained on 100-foot lines for reference. The operator for the free flight had 30 minutes training on the tether rig. This gives an indication of the ease with which future operators can be trained. The ducted fan's autopilot responds quickly and surely, providing a remotely controlled airborne unit with a high degree of hover stability and with the capability for true vertical takeoff and landing. A quick release mechanism was tried for the second free flight and was proven successful. This permits two men to launch and operate the vehicle from an unexposed position under high wind conditions. Performance, as well as stability and control response, were satisfactorily demonstrated. Balloons were restrained on 200-foot lines for reference during this test. The unit presents a small radar cross-section, and during hover or at slow translation speed, Doppler information is denied to the enemy. Because of the unit's small size, visual detection is difficult. The proposed unit versus the demonstration unit will consider refinements such as power plant with greater horsepower, optimized airframe and controls for greater speed, range, and endurance, adverse weather capability, optimized subsystems for weight reduction, and narrow beam communication. With feasibility of the General Dynamics unit conclusively demonstrated in free flight tests, General Dynamics has continued support of system studies and detailed technical studies. A powered wind tunnel model of advanced design incorporating an airfoil-shaped shroud was constructed and tested. Valuable data gathered in this wind tunnel test program has permitted detailed performance analysis of hover, transition and high-speed translation, and the pre-design of new applications. Flight simulations have been developed to evaluate various flight procedures and recovery concepts. System studies have yielded numerous practical applications for the VTOL ducted fan system in the areas of surveillance, communications, weapons delivery, and general close support. The results from the General Dynamics VTOL ducted fan program have set the stage for practical advancements in close support capability.